Okay, welcome back to our class. And today we are going to learn how to create models of electrical networks using Matlab and Simulink. For today's learning objectives, at the end of this activity, the student will be able to model second order system, use Simulink to model an RLC circuit, and then solve the transfer function using Matlab. Now let's start with this RLC circuit. So in the figure shown below, okay, you have here your voltage source denoted as VT in series with your resistor R, capacitor C, and your inductor L. Now the current that is flowing in the circuit is denoted as I sub T. All right. Now recall Recall that the voltage across your resistor is just the current multiplied by the resistance R. Okay? And then for the voltage across the capacitor, now we can create an equation that the current across the capacitor is just equals to your I sub t. Okay? And then that will become your C multiplied by dVC over dt. That's the current across your capacitor. Now, manipulating this equation and then solving for BC, it will lead you to this equation. So BC is now equal to 1 over C multiplied by the integral of I dt. Okay, that's the voltage across the capacitor. Now, for the voltage across the inductor, that is just equal to L multiplied by di over dt. I hope you can still recall the formulas in your previous circuits. Now, using KBL, now we can create this equation of Vt, that's the voltage source, is equals to the voltage across the resistor, Vr, plus the voltage across the capacitor, Vc, plus the voltage across the inductor, Vl. Now, equating, solving Vt in terms of I, so it will give you Vt is equals to I times R plus 1 over C integral of I dt plus L di over dt. Okay? Now, from this equation, we are going to create a model using Matlab Simulink. Okay? From this equation. Now, before we will create our model, we are going to manipulate this equation so that now the output of this will be L di over dt. And these are your inputs. Okay, take note. Now this is your summary. This is your input and this is your output. Take note of the output. Okay. Now, in this activity, now we are going to create a model and find the transfer function I as a function of time, so meaning this will be capitalized. So for that, I will change this to capital I, uppercase I over Vs. So where your resistor is equal to 1 ohm, your inductor is equal to 5 Henry, and your capacitor equals to zero point 0.2 farad. So we will try to solve uh, the transfer function of this using your Matlab and Simulink. Okay, now from your command window in Matlab, so please open your Matlab. Okay, you type Simulink, okay, to open your Simulink window. So in my case, now Simulink is already open, so it's here. So let me first delete this one. Okay, so this is my Simulink model. Let's create a blank model. So create a new model. So this is my new model. Let me delete this one first and then maximize this. Okay, this is my new model, untitled. Okay, so the file name here is untitled. First, now from the equation, let's go back to the equation. We are going to create a model out of this equation. Take note of that. So first, now we are going to put the summer here. Let's make it a little larger. And then let's change the sign. This is positive, negative, negative, where your positive now is your input. Okay, so this is your v as a function of time. Okay, and then take note, your output. Now let's go back to the output. This is your output. Your output here is L di over dt. So here now we are going to create a gain. So double click and put the gain here. And then label this as L. Okay. Okay. I will label this as L. Just click this one and click L. Okay. Take note. No, this is now your L. Oh, by the way, this is your L di over dt. This is wrong. This is not L. Okay. This is actually 1 over L. Why 1 over L? Hmm, let me first apply this one. 1 over L. Why did I put a gain of 1 over L here? So I use this gain 1 over L so that I can solve for my output I di over dt. Okay, di over dt. So since the gain here is 1 over L, okay, and L will cancel out, leaving you di over dt only. Okay, this is now your di over dt. Okay, now let me adjust this one. So since this is our di over dt, if I'm going to create an integrator, double click and type integrator and put it here, the di over dt will now becomes I as a function of time. Okay, this is now I as a function of time. This is actually L di over dit over dt. This is dit over, so that you will not be confused. Take note of this. Okay. Now, another integrator will be, we'll copy this one and put it here. Control R to rotate. Okay, this is another integrator. This will give you, take note, this is IT. And the output of this integrator will give you integral of IT. So this is integral of IT. Okay, so this is the integral of IT dt. Now, I'm going to, since this is now your di over dt, I'm going to create again here um, the gain. This will be my gain. I will rotate it here. So take note the gain is 1. Okay, this is L di over dt at this point, and this is your I sub t. Okay, now if I'm going to connect this to I sub t and then change this value to R, okay, the output of this will become your VR, right? This is now your VR. That is the voltage across your resistor. Okay, okay, I will just copy this one and I will change this to C. Okay, 1 over, this is 1 over C. Integral of IT dt. So let me, where is it? Where is my BT? So this is actually your VR, and this will be your BC. Okay, that's your BR, and this is your EC. So this is actually your VL. VL is equal to LDI over D. Okay, so this is your simple Simulink model. But now we will insert another output. So out one. So out one, connect this to the output. Since we don't have values for the input. So and we have also in one, type in, put it here. So this is now your in one. So I'm doing this because I want to calculate the transfer function. So before calculating the transfer function, you need to put in one and out one here. Okay, so because now we will be converting this later on. This model, we will be converting this model into state space. If you can still recall your state space model, that is the matrix model of your block diagram. We can do that later on. Okay, so take note, this is one and in out one. Okay, now next we are going to save the model here. So I'm going to save this model as RLC. Okay, this is my RLC model, and then let's go back to our Matlab command window. So Matlab command window. In your Matlab command window, we will be putting the values here. So R here is 1 ohm. So as what is stated here, take note R here is 1 ohm, L is 5 Henry, and C is 0.2 farad. So L here is 5 Henry, and C is equals to 0.2 farad. Okay, these are the values. So you press enter here, and then you can see here the values are now saved in the workspace. Okay, so the values are now saved in the workspace. Now, the first thing that we will do here is to convert the linear model, our model a while ago, the RLC, no, to a state space model. So state space model is denoted by A, B, C, and D. These are the values. These are the variables that we will be using for our state space. Okay, now this is A, B, C, D is equal to, by the way, we can eliminate this comma, just to put a space here, and then put lin mode. So this is your linear model, and then call on the the model that we have saved a while ago. So a while ago we have saved the model here. Where's the model here? So the model is RLC. It's the file name of your model, and then call on the model and then convert that to its equivalent state space. So press enter, and you will see the values of A, B, C, and D. Okay, we are going to discuss more of this now when we reach complicated block diagram. So for now, no, let's just imagine that A, B, C, D are the values of your matrices. A, B, C, and D. Okay, now, next thing that we will do is to create a transfer function by naming this as num stand for numerator, and then is for your denominator. This will convert the state space, no, to transfer function of your A, B, and C, and D. Now, A, B, C, and D are matrices. Okay. Now, the function SS to TF will convert state space, okay, to transfer function. So transfer function have numerator and denominator. So the numerator is stored in num, and then the denominator will be stored in den. So press enter. You can see here the coefficient of your numerator, and these are the coefficient of your denominator. Now, if you will call, if we will name our transfer function as TF, and we will call the values of num den, okay? So we have here TF stands for transfer function. Num then it will give you the transfer function. So 0.2s all over s squared plus 0.2s plus 1. This is your continuous time transfer function. So that's how you solve the transfer function now of a second order system. Now from the RLC circuit, we converted that to an equation. And then from equation, okay, this equation, we created a model. This is now our model. And then from this model, we calculated the transfer function. So that's it for today. I hope now you've learned something on how to solve or how to get the transfer function of uh, an RLC circuit. Okay.